This is lesson 11.7, three-dimensional figures. Study the shape of each common object below. Then compare and contrast the properties of each object. The cereal box has 6 rectangular faces, front, back, top, bottom, left, right. The soda can has only 2 faces, the top and the bottom, which are both circular. Its side is one side with no vertices and no edges. It is a cylinder. The birthday hat has 1 circular base and 1 vertex. Many common shapes are three-dimensional figures. That is, they have length, width, and depth. Sometimes called height. Some common terms associated with three-dimensional figures are shown below. 2 types of three-dimensional figures are prisms and pyramids. A prism has at least 3 lateral faces that are parallelograms. Top and bottom faces, called bases, are congruent parallel polygons. The shape of the base tells the name of the prism. A pyramid has at least 3 lateral faces that are triangles. It only has 1 base, which is a polygon. And again, the shape of the base tells the name of the pyramid, triangular or square in this case. Some three-dimensional figures have curved surfaces. A cone has 1 base. That base is a circle. It has only 1 vertex. A cylinder has 2 bases. They are both congruent circles. It has no vertices and no edges. A sphere, all points on a sphere are the same distance from the center. It has no faces, edges, vertices, or bases. Classifying three-dimensional figures. For each figure, identify the shape of the base, then classify the figure. In example 1, the figure has 1 circular base, no edge, and 1 vertex. It is a cone. In the second figure, the base and all other faces are squares. This would then be a square prism or a cube. In example number 3, the base is a triangle, and all the other faces are triangles. So this would be a triangular pyramid. In example B, its faces are circles, parallel congruent circles, and it has no vertices and no edges. Its sides don't have any vertices or edges. It therefore is a cylinder. Classify the shape of the body of the digital camera, not including the lens, as a three-dimensional figure. In this case, it would be a rectangular prism. It is front, back, top, bottom, left, right. The shape of the zoom lens as a three-dimensional figure. It has 2 circular bases and 1 side which has no edges or vertices. It would therefore be classified as a cylinder. For each figure, identify the shape of its bases, then classify the figure. In number 1, the shape appears to be a rectangle or a square. Let's say for the sake of discussion it's a square. All its other faces are triangles, so we would classify that as a square pyramid. Example 2, its base is a rectangle, or a triangle, excuse me, it's on its side. It has 2 triangular bases. Its other sides are rectangles, therefore it is a triangular prism. In example 3, two parallel congruent circular bases and one side that has no edges or vertices. This again is a cylinder. Number 4, has no faces, edge, or vertices. It's made up of a set of points, all the same distance from one point called the center. In example number 4, that would be classified as a sphere. This lesson has huge vocabulary, as you can see here. Students will need to have all that vocabulary in there notable and be responsible for knowing it for the test. We're going to jump to lesson 11.8 now, which talks about drawing three-dimensional figures. The front view of the Wright Brothers Memorial in Kitty Hawk, North Carolina is shown. Describe the two-dimensional figures that make up the front view. They appear to be a parallelogram and a trapezoid. Parallelogram is vertical, or horizontal, and the trapezoid is vertical. The monument is a three-sided building. Sketch what you think the top view might look like. Looks like this. Apparently two triangles and a circle in the middle. You can draw different views of three-dimensional figures. The most common views are top, side, and front. Draw the top, side, and front view of the figure at the right. The top view is a triangle, the side view is a rectangle, and the front appears to be a smaller rectangle, could possibly be a square. In example A, it says, draw a top, a side, and a front view of each solid. I've done that here. This top would go here, the side would go here, and the front would go here. In my second diagram, the top is actually the bottom. This is cylinder. You have a side here, and then let's see, the side over here, and then the front goes here. If you break them down into different shapes, this is what they look like. Draw a top, side, and front view of the video console shown. Here's the top, here's the side, here's the front. Draw a top, side, and a front view of the tent. Here's the top. Kind of hard to see from here. You have to look from above. This is the side, and this would be the front. Draw a three-dimensional figure. Use the top view to draw the base of the figure, a 1x3 rectangle. Add edges to make the base a solid figure. Use the side and front views to complete the figure. Draw a corner view of the three-dimensional figure whose top, side, and front view are shown. I've got it done here in example D. I'm going to make an attempt to draw a quick one here for you using my isometric grid paper and my line tool. I'll be doing it quickly. It certainly won't be a work of art, but you'll get an idea of how to do it. I've drawn the front. This would be the side. I would then draw the top. And with some allowances for the haste at which I did that, it looks pretty close to example D. Draw a top, a side, and a front view for each solid. You can see that that's been done down here. This would be the top. Kind of hard to see that. You have to look down from above. This would be the side right here. And the front would go right here. In example number 2, top is here. The side is actually on the back there. And then the front would be the three faces you can see here. Number 3, a transparent prism can be used to refract or disperse a beam of light. Draw a top, a side, and a front view of the prism shown. You can see that here. The top would be right here. It'd be hard to see that. The side is right here. And the front would go here. In number 4, it says draw a corner view of the three-dimensional figure whose top, side, and front views are shown. And I'll do the same thing I did here in the last example. This is what my finished product will look like in number 4. I'm again going to use my isometric dot paper and my grid to make a quick version of that so you can see how it's done. Actually, probably easier on isometric grid paper with a ruler and a pencil. But you get an idea of how you achieve that three-dimensional look. Like so. At this point, you should stop the video and go to my webpage or simply type in www.naiku.net and take lesson quiz 11.7. Thanks for watching.